Hello, today we are going to be using Sketchpad to make a isosceles right triangle and to graph the formulas for the hypotenuse, length, and the area. So to make an isosceles right triangle, we can actually use a square. So to create a square, you're going to select the line segment tool and create a line segment. Once you have that, you are going to want to go back to the pointer tool and make sure that you highlight and double click one of the endpoints and the line, and you need to double click that so that Sketchpad knows that that is the point of rotation. So then you just go, once all that is highlighted, you go to you go to transform and rotate at 90 degrees, and we get our second side of the square. So now we want to add on this endpoint over here, and again we're going to do the same thing with highlighting the line and highlighting and double clicking the endpoint. Go to transform and rotate, and then we're going to do it one last time, so make sure to double click and transform, rotate. So now we can see that we have our square, and now we are just going to label the points so we can make it easier on ourselves. So highlight all 4 points and then go to display and label points, and we are going to start with the letter A, and so it does it for us. And now we're going to want to create a diagonal to split the square in half, and this will give us 2 isosceles right triangles. So to do this, you just have to click the opposite endpoints. I'm going to use A and C, so highlight them, but you could also use D and B as well. So once you have those highlighted, you go to construct segment to cut it in half. And since we only need one of these triangles, we can hide the other half of it that we don't need. And just go to display and hide objects. So once we have our isosceles right triangle, we are going to want to measure the leg length, the hypotenuse length, and the area. So to confirm that it's actually an isosceles triangle, we're going to measure both leg lengths, and you just highlight and then go to measure length. And so that's going to call segment CB J prime, but it's still CB. And then AB, highlight and measure, and that's going to call it J double prime. And that is also 6.43 centimeters, so you know that they're the same, so they are so it's an isosceles. And then to do the third leg, or the hypotenuse, you highlight it and go to measure and length. So once we have those measurements, the last one that we need is the area. And to do that, you have to highlight the 3 points, A, B, and C, and then go to construct triangle interior. And it's going to shade and highlight the inside of the triangle. So then all you need to do is go to measure and area. Okay. So once you have all that, you can get rid of this J double prime measurement because we only need one of them. So now we're going to make a data table with the 3 measurements that we have. So you're going to highlight them in order and then go to number and tabulate, and it puts the values into a table for us, but we're going to want a few more values than just one. So you keep that highlighted and then go to number, add table data, and then you want to select the option that says add 10 entries every 1 second. So then what you do is you grab this point C and you can make your triangle bigger, and as you do that, or bigger or smaller, it is going to add more points for our graph. Okay. So once we have enough, it doesn't really matter the exact number, we're going to graph this by going to, or first you're going to highlight your table, and then you want to go to Graph and Plot Table Data. And so it's going to bring up an x and a y, and our x value is the leg length, and then our y value is the hypotenuse length. So go to Plot, and we see that we get a straight line. And so we're going to verify that it is actually a straight line by making it a ray. So you're going to select this first point and then any other point, and go to Construct and Ray. So once we have our ray, we can actually measure the slope of it, so keep it highlighted and then go to Measure and Slope. So the slope of the line E and F is 1.41. So now we're going to plot a new function, and to do this you just go to Graph, Plot New Function, and the formula that we're going to use is we're going to actually use our slope that we just got, which was 1.41, and then we're going to use x, and you can see that it continues right along that line, so we know that all the more points would also be on that line. So all of that was for the leg length and the hypotenuse length. So now we're going to look at the leg length and the area. So now just get rid of all of the points that you just made and the axes by just highlighting everything, and you can delete it. So now we're going to do the same thing that we just did. So select your table and then go to Graph and Plot Table Data. And this time we're going to change our y value but keep x the same. So keep x as being the leg length, but then change your y to the area. And go to Plot. And we see that this time we get a much steeper line this time. And so to verify this, we're going to plot a new function again. So go to Graph, Plot New Function. And this time we're going to be using the formula of 0.5 times x squared. And to x square it, you just use the little caret button right there. So this formula comes from actually the formula for area for a triangle. So the because the formula for a triangle is 1/2 times base times height. And so once this 0.5, it represents the 1/2, and then the x squared is the base and the height. So select OK, and we see that the points actually end up on a parabola. And that makes sense because actually the function of x squared is a parabola. So since it's on there, we can know that the formula that we used for the leg length and the area was correct.